think that works. All right, so I'm going to go ahead and discuss the section 3.3 measures of position material. There are several measures of position in the section 3.3. I'm going to focus in the beginning on two of them that we use quite a lot. The first is what I'm going to call the Z-score. So we're going to have a formula, and this is a formula we're going to actually need and have to use. So I'm going to tell you what it is conceptually, and I'll put the formula up here. Formula is very easy to use, by the way. It's not hard at all. So the Z-score gives the position of a data value relative to the mean in terms of standard deviation. If you look at the book, it says probably something a little bit different, but they're going to be equivalent. So let me give you a couple of examples before I give you the formula. So we took a look at IQ, had a mean of 100 and a standard deviation of 15. So there's the 100 in there, 15 up, there's 115, another 15 up, there's 130. Suppose that was your IQ, 130 exactly. How many standard deviations did it take to get from the mean to the 130? I had to take 2 steps of 15 units to get from 100 to 130. So if x is equal to 130, the z-score is equal to 2. Now let's take a look at it in the other direction. I didn't put this in there before, but if I'm going down, I'm going in a negative direction. I'm subtracting 15 to get to 85. So if someone had an IQ of 85, how many steps of 15 did it take for me to go to 100 down to 85? Took me a single step. So if the x-score here is 85, the z-score here is -1. So you can see that it renders a score in terms of how many standard deviations above or below the mean that given score is. So let me give you the formula and then we'll talk about properties. We have 2 formulas for z-scores. For a sample, we have z equals x minus x bar all over s. For a population, we have z equals x minus mu all over sigma. There's no hard and fast rounding rule here. I usually just put the rounding rule in the problem. Our book seems to like 2 or 3 decimal places. but there it is. Now, there's a couple of interesting things about how the process works. And I'm going to run through that with an example, and then we'll talk about the properties. So we have a sample. Maybe we're measuring vehicle speed, 65 miles per hour, with a standard deviation of, oh, I don't know, 6 miles per hour. Suppose my speed is 72 miles per hour. Do we have a Z-score here? We certainly do. Now, I'm going to put way more detail into this little example than I usually do because I want to bring out some of the property notion stuff. So my speed is 72 miles per hour minus the mean of 65 miles per hour divided by 6 miles per hour. 7 miles per hour divided by 6 miles per hour. And before I reach for Mr. Calculator, I want to stop here and note that because we have mile per hour on the top and mile per hour on the bottom in a simple fraction, they cancel just like common factors. So these guys here are gone. So there are no units in my Z distribution. So Z is equal to 7 over 6. Z equals 7 over 6 is 1 point. And then you'll reach for your calculator. 7 divided by 6. If I round it to 3 decimal places, I get 1.167. So working with the Z-score is not particularly difficult. It's important to realize a couple of things about this. They are positive when X is greater than the mean. They are negative when X is less than the mean. There are no units. So regardless of what it is you are measuring, that was miles per hour in the sample, but the miles per hour went away when I recorded or evaluated the Z-score formula. So it's important to remember that there are no units at all. It's what we call a dimensionless number. I don't use that phrase in class, but as a regular thing, but that's what it's called. There are no units involved. So there's a couple of basic properties here for your Z-scores. All right. Now, next up, and this is probably where I'll end up for the night, I'm going to talk about quartiles and box plots. They're friends. All right, so if we divide a data set into quarters after putting it into some sort of order, we have quartiles. They are similar to the median. Now, remind you from the median, You have your minimum data point there. You have your maximum data point there. You have your median right there. 50% of values are above the median and 50% of values are below the median. So the median has already been discussed, and that really kind of lets us know what we need to do when we want to talk about quartiles. We're going to take the median and each of these 50% of values, and we're going to split it again. We're going to call this guy Q1. The median also goes by the name Q2, and we're going to do it out here again, and we're going to call that Q3. So we have 25% of my data values, 25%, 25%, and 25%. So you can see how that works. What does confuse students is when it comes to values that we use to discriminate our quartiles, there's really only 3 numbers with the little q. There's Q1, Q2, Q3, and half the time we call Q2 the median anyway. So people think, oh, there should be 4 numbers. And well, no, there's not 4 numbers. There's actually 5 numbers. There's the minimum number. There's the Q1 number, the Q2 number, the Q3 number, and the maximum number. So those 5 numbers form the basis for our quartiles and our box plots. Our calculator does a very good job of finding these values for us. It's nothing that we need to search for. So let me go ahead and I'm going to reach over here and start up Mr. Calculator. I think I'm going to want to run through an example. What time is it? 4:40. I got 10 minutes. I think I can do this. Oh, 20 minutes, 4:40. So give me one moment. Getting it all ready. Okay, I think I'm ready. Okay, so quartiles and box plots. Let me talk just a little bit about what the box plot looks like. And then we'll take a look at them on our calculator. One of the things I have you do is have you generate box plots on your calculator using data sets, sample data, and the like. So if we're given a data set, a box plot starts with a box. There's a line somewhere in that box. And then it's got 2 lines coming out from the left and the right side of the box, as you see. Sometimes they're called box and whiskers plot. Much more cute, honestly, but whatever. And there's really a numeric scale involved for our x's. So if this was on a number line, I would be seeing on my box plot the minimum value, Q1, Q2, which is our median, Q3, and then the maximum. And again, each of those will contain 25% of the values in the data set. like that. That's a box plot. Very easy to draw, by the way, as long as you have access to the 5-number summary, as we like to call it. So let me put this away and bring in a fresh sheet of paper. Let me put in a reasonably sized data set. So let's look at, what do we want? Do we want babies or speeding cars? I think I'll do speeding cars. Well, vehicle speeds. And they'll be in miles per hour. And there's a couple different places these keystrokes exist. Soon enough, they're going to exist in this very video. But they won't be the only place to find them. So I'm going to have a sample of, let's see, 10 to 12 numbers. Let's see, 63, 65, 59, 47, 61, 72. That's 1, 2, 3, 4, 5, 6. 73, 72, 54, 61, 60, and 89. Oh my God. All right, there's my data set. Now, this gives me another chance to go through the keystrokes for our basic analysis. If you view the videos, depending on which videos you view, if you look at your text, you're going to see, and if you look at your text, you're going to see a formula. It's important to realize that we use our calculator as absolutely much as possible. We use it whenever we can. There is a way of doing standard deviation, for example, longhand using a table, which is honestly just really tedious. And I'll have a video on that sooner or later. But right now, let me go ahead and share my screen. All right, there's the calculator. You guys should be able to see my TI-84. All right, so you've turned your calculator on, you're ready to get going. You're in stats, so you hit the stat key. You see edit, you want to enter in data, you know that's where you're going to go. And then you see that there's some data in list 1. I'll scroll to the top and highlight the list name. I'll hit clear, followed by enter. That clears out my list. And by the way, I could have used any of my lists. I just want to go through that method of clearing lists. So 63, 65, 59, 47, 61, 72. If you make a mistake, you can scroll back up to that number and fix it if you need to. 73 and 72 again. 54 and 61. And 60 and 89. All right, my data's in there. I've got 12 numbers in there. I'm going to go ahead and use the keystrokes I use to find things like the measures of center, mean, and variation, standard deviation. I need to remember where my data is, stat, calc, and let's see, this has been bugging me lately. Yes, I've got my calculator in this mode. If your calculator is in the other mode, I'll take a look at that in a moment. What I need to do is I need to point the one variable stats at my list. If I look at the number 1 key in blue, I see L1. So second, L1 brings that into play, and I hit enter. And my calculator does all the heavy lifting for me, finds the mean, the standard deviation. And down below the sample size are the numbers that I'm interested in. So I've got a minimum of 47. Q1 is 59.5. Q3 is 72. The maximum is 89. So I can go ahead and note those values and construct a box plot using those values. But I'm going to go ahead and have my calculator construct the box plot for me. And yes, I'm going to go through the keystrokes twice. So I will notice above the y equal key, we have a key called stat plot. I swear, your calculator really does want to help. It calls out stat all the time. So second, stat plot, and brings me here. Now, if you're going to follow along and you're trying to keep up with my keystrokes, to avoid issue, the first thing you want to do is to scroll down to option number 4 that says plots off. This is going to avoid confusion, and it's going to ensure that you're going to see only the graph you wish to see. I have to hit enter, and then I have to hit enter one more time. It's just brought it up. Now it's done. And if I go back to stat plot, they're all off. I have access to 3 plots that I can use. I can use them all. I can use 1, I can use 2, I can use all 3 if I need to, but I got to be very careful. Sometimes they don't play well together. And if I want to ask plot 1 to do one type of plot and plot 2 to do another type of plot, then I might not get what I want. I might get an error message, honestly. So I'm going to use plot 1. I'm going to hit enter. And it's turned off right now. And you can see to turn it on, I'm going to hit enter one more time and it switched it on. I use my down arrow key. And this brings me to the type of graph I wish to draw. There are a number of different types. There's one for histogram that honestly, the juice ain't worth the squeeze there. This is a form of box plot, but not the one we want. This is our basic box plot. So I select that and I hit enter. Once that's been selected, I can come down here and select the list. My data was in list 1, so second L1 puts the data in correctly. Frequency is 1. That should be hardwired in there. If you want to get artistic, you can change the color. Now, before I do anything else, I'm going to show you a most important key. It lives under the zoom key. If I scroll down under the zoom key, option number 9 is zoom stat. This is truly an important key. It's going to place your box plot on a plane. The plane is infinite. If you're looking in the quadrant 2 and your graph is in quadrant 1, your calculator will never see the graph. So I select stat plot and then I hit enter. Ooh, and that's what I get. That's my box plot. Now, a couple of things about the box plot. I have a key here called trace. If I hit the trace key, I can trace those 5 numbers out. Left key takes me downtown, Q1 minimum. Right key, I go uptown, Q3 maximum. That's my box plot. All right, I've got just a few minutes left. Are there any questions? Let me stop my sharing. Let's see, nothing in the chat. So, as I say, that box plot, let me jump back over and go through those keystrokes one more time. I need my data in my calculator. I need to calculate the one variable stats. That enables my calculator and me to know the min, Q1, Q2 or median, Q3 and max values. I've got to know those first. My calculator needs to know those first. Then it's second to stat plot. Select plot number 1, make sure it's turned on. If it's turned on, make sure you've got the correct graph selected, then select the correct data. I'm going to change the color. Yeah, blue looks good. And then under zoom, all the way down, zoom stat. There you go. If you want, you can play around with trace, but that brings up the graph. You can print more than 2 of them on a, you can print more than one on a screen at a time, probably up to 3 because we have 3 stat plots. So that enables people to do comparisons. Let me run through a very quick example of that. If I put a bunch of numbers in over here, like 35, 32, 21, 12, 54, 45, 6, no, not 60, 26, 1 more, 2 more, 3 more, 4 more, 5 more. So now I've got data in 2 places. So now I can go ahead and turn on plot number 2. Turn that on. Select the stat plot. It is pointed at list number 2. It'll go there to get the data. I want a contrasting color. Zoom. Zoom stat. And there you go. And you can see them both on the same screen. Honestly, I don't believe I asked you to do that at any point in time during a quiz or an exam. You do need to be able to generate at least one of these little guys, but there you go. So that pretty much wraps it up for tonight. I'm going to stop the recording.